All right, guys, don't usually do this, but I'm making a video of the morning tutoring session because, well, tutoring got canceled at the last minute. So I'm going to go through these questions. It's going to be pretty quick. Obviously, just fast forward to the ones you need to see. This first section is just the basic properties about angles. You see that thick dot in the center, or near the center? That means it is the center. So these are central angles that are going to be the exact same size as their arcs. Vertical angles are going to be equal. Linear pairs are going to add up to 120. Diameters cut the circle in half. So that's another way to know this is 120 over here. So we got 60s and 120s all around. Over here you have an inscribed angle. The vertex is on the circle. If the arc is 100, then the angle is going to be half that at 50. If there was like another line that, maybe there's a line that's like right here or something like that, like would that affect what arc we use? No. Be real careful on this test. Make sure you're using the correct arc. Follow the line to its endpoints, or to where it hits the circle, and it's the arc between those points. I don't care what else is going on. Inscribed and central, those are the two that I'm looking for first anytime I'm doing one of the big angle problems. Inscribed and central angles have one arc. So if I know the angle, then I know the arc. And if I know the arc, then I know the angle. So I'm working on those and I'm looking for diameters all the time. Okay, after that, if I can't figure it out, I go to interior angles. Interior angles, well, obviously those are going to be vertical, they're equal. But you follow the angle to the circle. So this angle has this arc, I'm going to call it x. The vertical angle has this arc, that's 40. So we know that the arc in front of it, x, plus the vertical arc behind it, 40 divided by 2, has to equal the angle. Make sure it's with the angle you want. If you're like looking for this angle, for instance, that would be the arc in front and behind would be top and bottom. Pay attention to which angle you have and which arcs you need to use. So x plus 40 equals 120. So x would have to be 80 in this case. Or if you got a good eye, you're like, okay, 60 is the middle of 40 and what number? Well, 40 plus 20 is 60, plus another 20 would be 80. There's other ways to get there, but that arc has to be 80. If you're outside the circle, call this x, that's an exterior angle. You're going to do big arc, so you follow it to the circle. Pay attention to which arcs. These are the two hits on that side. These are the two hits on this side. We need this big arc over here. Well, 100 plus 20 plus 100, that's 220. 360 minus 220 is going to be 140. This arc is going to be 140. So what do? We do big arc 140 minus small arc 20 divided by 2. That's going to be 70 minus 10. That's going to be 60 degrees. This angle is going to be 60 degrees. Nailed it. So these two types of angles are a little bit tougher because they involve two arcs. So two arcs and an angle. If you know two of the three things, can you always get the third thing? Yes. All right, so here's a more complex picture. You're going to have a complex picture. Again, that's the center of the circle because it's kind of a thick dot. That I believe the test words it much better. I'm looking for central angles and inscribed angles. Well, if that's the center, then we know that this orange line is a diameter. Let's not forget that. Always looking for diameters. The angle next to it would be 60. This arc would be 60. This arc, which is kind of big, that whole thing is 120. I'm going to leave that alone for now, but that whole thing is 120. So that's really all I can do with that. I don't see any inscribed angles I can deal with. I do have an interior angle that's 30 degrees that opens up to 20. Well, that's 2 out of what we know is 3 pieces. So we just did this a second ago. The angle behind it would open up to this small part. So I'm going to call that x for right now. So 20 plus x divided by 2 has to equal 30. So 20 plus x has to equal 60. X has to equal 40. Or if you could be like, okay, 30 is the middle of 20 and what number? Well, it has to be 40. Okay, well, that's really helpful because we knew all of this was 120. That means this part has to be 80 over here. So we have 60, 40, 80. When I get totally stuck, I ask myself, hey, what are some things I haven't used yet? I haven't used this 55 yet. Is there anything I can do with it? Let's follow that to the circle. Let's follow that to the circle. Where are the spots that it hits? Hits boom, boom. It hits boom, boom. Again, like this spot here has nothing to do with this angle. Make sure you're paying attention. It's the whole thing out here. All right, well, we know two of the three things. We know the small arc, we know the angle, we can get the big arc. I'm going to call this whole thing out here y. So the big arc y minus the small arc 40 divided by 2 has to equal 55. So y minus 40 has to equal 110. So out here, this big whole thing is going to be 150. All right, well, if that whole thing's 150 and that part of it's 60, we know that this part of it has to be 90. And then we have one little arc left over here. Right, we know that this part's 90. Well, again, we have a diameter. Do you want to die? Yes, I want a diameter all day. We have 90 and 20, that's 110, so this part would have to be 70. All right. Also, I forgot to do this earlier, like we know that this is a four-way stop, so we can get all four angles at that intersection. Boom. This is 90, and now I can, if I follow it back, I can get this inscribed angle. Half of 90 would be 45. 45 plus 30 is 75, so this would be 75, 105, 75, 105. There's a lot to it, but like this is another inscribed angle that opens up to 20 and way over there. So 60, 20, and 90 would be 170. 170 divided by 2, this angle is going to be 85. That means the one next to it, that's this entire thing, would be 95. I'm getting real messy over here. If that's 45, the one next to it would be 135. And then one more angle down here. This one's kind of icky, but there actually is more than one way to get it, but the only way you would really understand, or no, I shouldn't say it like that. The only way we've really talked about is maybe using this four-sided shape. So 120, 105, 85, what does that add up to? That'd be 190, 210, 310. So that would leave me with 50 degrees for that spot. I just went really fast, but the basic premise is I used what they gave me. Once I couldn't use the 120 anymore, I got 60, that was about it. I was like, okay, what else do I have? I went to the 30, I was like, okay, I can work with that. I was able to get this arc. I was like, okay, I'm totally stuck again. I used the 55, I had the 40, I could get the big one out here. That helped me a lot. So that there were things that I could keep doing. So keep looking, ask yourself, what have I not used that they gave me? Look for triangles, look for quadrilaterals, look for central angles, look for diameters, look for things that you can actively use. All right, segment stuff. So what is the property when it's chord? It is part 5x minus 21 times part x plus 4 equals part x minus 3 times part 3x plus 3. You must fully distribute. I'm not going to do this on every problem, but you're going out. Sorry, you're not. You're going first with first, 5x squared. Then outside, that's plus 20x. Inside is negative 21x for an overall effect of minus x. Write it out if you need to. I've been asking you to try real hard to do that in your head. And then last with last, 21 times 4, minus 84. Lots of students are messing up signs, like they're doing all the distribution right, they're getting the right numbers, but they're putting things like plus 84 and getting the whole thing messed up, and then they're wrong. There's not a lot of partial credit here. That's a negative times a positive. You need to understand that. Even if you're using those baby calculators and it's hard to type in a negative, you just need to know what a negative times a positive is. That's on you to know. Equals, same thing over here. First with first would be 3x squared. Outside, that would be plus 3x. Inside would be minus 9x. So plus 3 minus 9 is minus 6. And then last with last would be negative 9. All right, something I've seen people do is like to divide this side by 3. Am I allowed to do that? No. I cannot divide this side by 3 unless I also divide this side by 3, which I don't want to do. That is not what you do. Make it equal to 0, then see if there's a GCF. So we are going to combine like terms. We're going to get everything on one side, then look for a GCF. Your goal right now is to make one side 0 and keep x squared positive. So to do that, I need to move the 3x squared over. That would give me 2x squared on the left. I need to add 6x. Again, pay attention to signs. I think that might be I think people are making that mistake more than almost anything else. is they're doing the wrong thing based on the signs. Either they're getting the wrong sign initially, or when they move it across the equal sign, they're not doing it correctly. This would have to be plus 6x to move it across an equal sign. So that is plus 5x. Add 9, that would be 81, what was it? 84 plus 9 would be 75. Minus, see, I just messed up. Minus 75 equals 0. All right, and then factoring. You got to know how to factor. Different teachers teach it different ways. I'm going to just do it the way I've been doing it, but you either do it the way I'm doing it here, or you do factoring by grouping. You have to know how to factor, though. So you do A times C, 2 times negative 75 is negative 150. It's important to know that it's negative. Because it's negative, we know that the factors have to subtract. If it was positive, the factors would have to add. But it's what factors of 150 subtract to equal 5. It's kind of a big number. I'm going to go with the most obvious option first. That's 10 and 15. And yeah, that's it. 10 and 15 subtract to equal 5. It would have to be minus 10 plus 15. So what are these numbers? These are the numbers that you need to get when you distribute. That is your outside and your inside distribution. So when we do our outside and our inside distribution, this needs to be the answer. So here we go. We know that the first number is 2x. 2x squared. To get 2x squared, it must be 2x times x. There's no other choice. Well, if it's like a 1 times anything, I can get whatever I need. So can 2 get me one of these numbers with distribution? The answer is yes. 2 times negative 5 equals negative 10. So now my outside distribution is negative 10x. Got it. What about my inside distribution? I need 15. Plus 15. 1 times 15 is 15. So there I now have minus 10 plus 15, which is plus 5. And then check, what's 15 times negative 5? Is that negative 75? Yes. So I have my factors. And then I'll show the whole thing real quick. We need this number, 2x plus 15, to be 0. So you would subtract 15 and divide by 2. Same thing here, x minus 5, we need it to be 0. So you would add 5. So that's what x equals, but would they both work? Well, when I plug in a negative, what's a negative minus 3? I don't even care what the number is. A negative number and a negative number make a bigger negative number. So that's not going to work. How about 5? 5 minus 3, that's good. 5 times 5 minus 21, that's good. And then, of course, these are going to work. They're all positives. So x equals 5 is going to work. If they said, like if this was AB, and they said, how long is AB? Make sure you answer the question. If both answers worked, make sure you circle both answers. All right, I'm going to do the rest of these a little bit faster. I'm not going to show every little detail like I did on the first one. What's the rule here for secants? It is the outside part, x plus 9, times the whole thing. The whole thing is all of this added together. Boop. It'd be 2x plus 6. It is outside x plus 9 times the whole thing, 2x plus 6, equals outside x plus 3 times the whole thing, 4x plus 4. Please be careful. Do not do outside times inside. Do not do inside times the whole thing. Like, I've seen all kinds of random things going on here. It is outside times total. And then we distribute. I'm going to go a lot faster. Hopefully you can distribute. It is 2x squared. This will be plus 6 plus 18 is plus 24x plus 54. Equals, over here, we'd have 4x squared. Plus 4 plus 12 is plus 16x. And then 4 times 3 is plus 12. We're going to get everything on one side. I'm going to keep x squared positive. So I'm going to take this side and move it to the left. That would be 2x squared minus 8x, and then 54, 44, 42 minus 42 equals 0. This time we do have a GCF. We can divide everything by 2. But please don't do that before you make it equal to 0. Make sure you're doing it correctly. X squared minus 4x minus 21. And then this is the factoring we've done all year. This is like a 1x squared. Well, the only way to get 1x squared is x and x. So it's just going to be the numbers. What are the numbers? What factors of 21? It's negative 21. So they need to subtract to equal 4. That's going to be 7 and 3. and I need -7 and +3. Why? Because the answer needs to be -4, right? So 3 minus 7 is what I need there. And then what would make the first one 0? -3. What would make the second one 0? +7. Plug them in. Well, I can see right away, -3 is a no-go. +7 is going to work everywhere. I'm feeling good about +7. Again, make sure you answer the actual question. If they ask you how long something is, you're going to have to plug it in. All right, what's the rule for two tangents? Well, technically it's outside times total, but the outside is the total. So, you could square both of them, but what would be the very first step? It'd be square root. So the rule ends up being is that tangent equals tangent. That's the rule. So they're just equal to each other. So 3x squared minus 7x plus 1 equals 2x squared. And oh no, I can't remember. I did this yesterday. I can't read my own handwriting, but I think it's supposed to be 17. I think we realized it was 17x yesterday. All right, I'm going to go with 17x. Because sometimes when I write 7s, it kind of pops back out. I think it just kind of popped back out. That's a 7. Yeah, let's get rid of you right there. Okay. Oh, yeah, it's definitely 7. You can tell now for sure. All right. So get everything on one side, keep x squared positive. Get everything on one side, keep x squared positive. Did you hear those things? So many people not doing that. Sorry, I didn't mean to yell. Subtract 2x squared, we get x squared. Add 17, we get plus 10. Pay attention to the signs. My goodness, the number of people getting signs wrong, and it's just killing them. Killing them. Add 15, we get plus 16 equals 0. And that does factor. This is just a 1x squared again, so what factors of 16 add up to 10? That's the question. It's going to be plus 8 and plus 2. So x equals -8 or -2. Because of the last minute switch to the baby calculators, we're going to let you just be done right there. You do not have to check the validity of these answers. It'll say on the test, you do not have to check the validity. So don't take the time to worry about having to plug that in and figure out all these things. So that should save you some time. Just assume they both work and move on. I don't even know on this one if they both work. It doesn't matter. But my feeling is that they both do work. Actually, they do. I can tell. So they both work, but we're moving on. All right. Equation of a circle. So I gave you a center point and a point on the circle, right? So if I draw a circle, if I give you a center point and a point on the circle, what is that called when you connect them? That is the radius. So I need the distance between these 2 points. People teach distance differently, but the distance is the square root of the change in x squared plus the change in y squared. So on this one, how far apart are my x's? They are 3. We do not care about positive or negative. We're going to be squaring it. It's distance. It's going to be positive. We don't care. So just 2 to 5, it's 3. Nailed it. 11 to -1, it's 12. Boom. And then the actual formula of a circle, if you can recall, is x minus h squared plus y minus k squared equals r squared. So we're going to square this number. It's going to undo the square root. So there's no reason to do the work to take the square root. It's just going to be 9 plus 144, which is 153. All right. So that's the number, right? The square root cancels out the square. So here's my center. This is my h and my k. So my final answer is x minus 2 squared, y minus 11 squared equals just 153. It's technically the square root of 153, right? That's the radius. But what are we doing to the radius? We're squaring it. So r squared is 153, which is what we have to plug in. And that's your final answer. So if you have the center and you have the radius, you can always get the equation of the circle. All right, this problem every single time. So the questions haven't changed in a long time. You're going to see the same questions on the test again. It's about knowing the algebra. But if you have a chord, a distance, it says a chord is 8 units from the center. I have drawn this picture every time I've done this question. I suggest you do the same. You draw a center, you draw a chord. This would represent the distance from the center, which will, of course, be at a right angle, and that cuts the chord in half. And then you finish the job, you finish the right triangle with a radius. This is the picture you draw every time, and then you figure out what you actually have. They gave us an area. Well, we know that area is pi r squared. If they gave us a circumference, we would know circumference is 2 pi r. So they could give us, something random. Well, not too random, actually. There's only a few things, but it's 289 pi equals pi r squared. The pi's cancel out. You take the square root. The radius is 17. It's technically plus or minus 17, but an actual length can't be negative. So the radius is 17. It says it's 8 units from the center. That's a triple. So the third one has to be 15. What is the length of the chord? The chord equals what? 30. Remember that if a radius is perpendicular to a chord, it cuts it in half. And even though that's not the whole radius, it's part of a radius, so it still has that property. But you're drawing that picture every time. You're plugging in the right numbers. There's going to be a Pythagorean theorem or a triple involved. All right, on the test, you're going to have a question just like this. It's just solve the system. So remember, it was a big quadrilateral, and you had to know opposite corners add up to 180. I did away with that. It's just a system. It looks just like this. Your first job is to get it in the format of ax plus by equals c. So that's job number one. So on the first one, I'm going to take the 3x and move it over. That's going to give me 4x. I'm going to take the 3y and move it over. That's minus 3y. You better pay attention to your signs. You're going to be a sad puppy. I'm going to take the plus 10 and move it over. That's going to be negative 26. So there's the first equation. The second equation, I already have a negative 3x. I'm going to leave that alone. I'm going to add, wait a second. I don't remember it canceling out so easily yesterday. I'm going to add 3y. Oh, there's a 2y already over there. I was like, I did this problem yesterday. Okay, there's a 2y. There's a 2y. I didn't see it. So when I add 3y, I get plus 5y. And then I'm going to leave the 25 alone. Okay. Yeah. So the goal here now is to do elimination. You can cancel out the x's or the y's. It doesn't really matter. I am going to cancel out the y values. I don't know why. I don't know why. I'm going to know why. All right. So here we go. So I'm going to do times 5 to this row, and I'm going to do times 3 to this row. The goal is to make the y values the same number but opposites. So when I do times 5, that's negative 15. When I do times 3, that's positive 15. Well, what's going to happen with a negative and a positive 15? They're going to cancel out. But I have to distribute the 5 to every number and the 3 to every number, or it won't work. We talked about that in class. 20x minus 15y equals negative 130. On bottom, negative 9x plus 15y equals 75. So we get 11x and we get 30, 55, negative 55. So x equals negative 5. From there, we plug in x. It does not matter where. I'm going to do this row here. So that would be negative 3 times negative 5. I'm plugging in the x. Plus 5y equals 25. So that would be positive 15 plus 5y equals 25. So 5y equals 10 and y equals 2. I told you I was going to know why. Boom. And there's your answer. Moving on. Find the intersection. These can be a little bit of work. I'm going to go quick. We've done it before. You can go watch other videos if you need better explanations, but your first step is to plug in the y value. So we have x plus 1 quantity squared. We have negative 3x. Now this is negative 3x minus 7 minus 1. So what is minus 7 minus 1? That's minus 8. We close it. We square it. Equals 25. We square this out. X squared plus 2x plus 1. Remember that this is x plus 1 times x plus 1. You're distributing that out. We've talked about how that works. I hope you don't understand that. If you don't get it, you're going to have to go watch another video, but there's not a lot of time, my friends. Plus, we're going to square it. What is negative 3x times negative 3x? That is 9x squared. What is negative 3x times negative 8? That's plus 24, but you would have that twice. That's plus 48, and then negative 8 times negative 8 is plus 64. Don't forget your 25. Then we're going to combine like terms and make that side 0. So we have 10x squared. We have 50x. We have 64. That's 65, but we're going to subtract the 25. So we have 65 minus 25, and that's going to be plus 40 equals 0. I've told you for these specific questions, you will always have a GCF that you can divide by. So x squared plus 5x plus 4 equals 0. That is x plus 4, x plus 1. I know we're going fast, but we should know how to, well, we've talked about factoring. Hopefully that's something we can do. And then x equals negative 4 and negative 1. But wait, you got to plug it in. So we have two answers, two coordinates. So if I plug in negative 4, negative 3 times negative 4 minus 7, I would get the coordinate negative 4 comma 5. And then negative 3 times negative 1 minus 7, right? I'm plugging in here to get the y value. That would be 3 minus 7, that would be negative 4. So negative 1 goes with negative 4. That is the final answer right there. It's two coordinates. And then one more question. Completing the square. What do? We are going to get our x's together, our y's together, and then our constants on the other side. I want my numbers to be positive. So I'm going to take this and move it over. That's going to give me x squared. I got a plus 31x. I'm going to move over. So 31 would give me a minus 30x. And then I'm going to leave room for a third number. Plus, I'm going to move my y squared over. I have a negative 3y I'm going to move over. That would give me minus 4y. Leave room for a number. And then I have my constant, which is 22. All right, so how do I finish this? I need to know what can I square to get negative 30 in the middle, and that's going to be minus 15. I'm going real fast. You can go watch the completing the square video. So what would complete the square? Plus 225, right? 15 times 50 gives me plus 225. Plus y, what would give me, oh, I put plus negative 4y, so it's just minus 4y. What would give me a negative 4y in the middle? Minus 2 would give me a negative 4 in the middle. When I square that out, I get a plus 4 at the end. So if I add 4, I got to add 4 over there. So then I got to add those numbers together, 225, 229, 249, 251. I think I got that right. And we're done. Woo! Big video, big tutoring. Watch the ones you need. I know I went fast at the end. I got to go do my thing now. Love you guys. Hopefully that helps.